Hi, welcome back to my YouTube channel. If you are watching this channel for the first time, please give it a thumbs up and subscribe for more videos. Today, we are going to look at scalars and vectors. Scalar quantities. So what are scalar quantities? Some quantities have magnitude or size. They can be measured by their magnitude or size, but they don't have direction. So such quantities are said to be scalar quantities. So in other words, we can say that scalar quantities are those quantities that have only magnitude with no direction. So let us see what we have on the board. Scalar quantities are those quantities that have only magnitude or size with no direction. Their examples are length. Length is also the same thing as distance. We have mass, volume, density, time, speed, temperature, energy, and area. Now, how do we mean by they have only numerical value or magnitude or size? It means, for example, if we say that this object A has a length of 50 meters and the object B has a length of 20 meters, we can add them together the way we add ordinary algebraic expression by saying A plus what? B. So we can add them together. We now have 50 plus 20. What is it going to give us? It's going to give us what? 70 what? M, which is 70 meters. So this is how we can add scalar quantities, but we can't say more about their what? Direction, because they don't have what? Direction. So let us look at vector quantities. Vector quantities, they are these quantities that have both magnitude or size with direction. So such quantities are said to be vector quantities. Vector quantities are those quantities that have both magnitude and direction. I will underline this magnitude and direction because they are very what? Important. If you are solving for a vector quantity and you're able to get the magnitude or the size or the resultant without solving for the direction, that means your answer is what? Wrong. Because for a quantity to be a vector, you must find the magnitude and also find the what? Direction. So these are the examples of vector quantities. Have displacement, velocity, force, weight, acceleration, momentum, moment, electric field, and so on and so forth. So these vector quantities, they are added by geometrical what? Method. Unlike that of the scalar quantities that we can add with ordinary algebraic expression. Geometrical method means that we can use the four cardinal points to get the sum of the vectors, or we can look at the direction in which they move to get the sum of the vectors. I want you to watch this video to the end so that you can understand how we can get the resultant vector. How can we represent a vector? So let's look at vector representation. A vector is represented by a straight line which has an arrowhead. The length of the line drawn represents the magnitude, while the arrowhead indicate the direction of the given vector. What are they trying to say? If you see a straight line that has arrowhead, that means that is a vector. Then this length of the line means what? Or represents the magnitude, while the arrowhead indicates the what? Direction of the given vector. Since we have force as a vector, velocity as a vector, so you can see something like this. You can see 50 what? Newton. Because force is measured in Newton, it can serve as a vector. You can equally see 40 meters per second. Because velocity is a vector, it can still serve what? As a vector. So let us see how we can add vectors. Addition of vectors. Two forces P and Q of 5 Newton and 4 Newton respectively act on a body in the same direction. The resultant vector is given by. So see how we can add these vectors because they are acting in the same direction. Okay, the first force has a magnitude of 5 Newton, while the second force Q has a magnitude of 4 Newton. Since they are acting in the same direction, P is pointing this way and Q is pointing this way. So both of them are acting in the same direction. We want to see how we can get the resultant vector. Because they are going towards the same direction, we are going to add the two forces together by saying the resultant vector R is equals to P plus what? Q, which will give us 5 plus 4. When we add them, it's going to give us what? 5 plus 4, I'm going to have 9 Newton. Why do I get 9 Newton? Because both forces are acting in the same direction. So let's assume they are acting in opposite direction to each other. What will be the resultant vector? So let me draw the diagram to show you. Let's assume that this is going towards the same direction. So I have P going this way. I have 5 Newton, that is P. Then I have 4 Newton, that is what? Q. What will be the resultant vector? Because both of them are moving opposite to each other, I'm going to subtract. So the resultant vector R is going to be P minus what? Q, which will give me 5 minus 4. I'm going to have 1 Newton. Now, we added these two vectors together to get a single vector, which is what we call the resultant vector. Also, we subtracted to get a single vector, which is what we call the resultant vector. So I want to tell us what is resultant vector and how we can get a resultant vector. Resultant vector. The resultant vector is that single vector which will have the same effect in magnitude and direction as the original vectors acting together. It means that any resultant vector will have the same effect in both magnitude and direction, and they will act as a single what? Vector, and they will also act what? Together. Remember that I told you earlier that if two vectors are acting in the same direction, you're going to do what? Add them together. But if two vectors are acting in opposite direction, you're going to do what? Subtract them. So I'll be giving you assignments so that you can be able to see whether you're following the class or whether you understand how we can add vectors. Believe me, it's very, very simple. So let's look at the assignment. A body is under the action of two forces, 7 Newton and 10 Newton. Find the resultant of the two forces. If I, the forces are parallel and act in the same direction. I, the forces are parallel and act in opposite direction. So guys, I want you to solve it and drop your answer in the comment section. And please, if you are watching this video for the first time or this channel, please subscribe to my channel for more videos. Give it a thumbs up, share and comment. See you next time. Bye.